Now we have representing relations. What do you think about representing relation? What's in your mind? Representing by what? By matrix. So you have matrices representation. What do you mean? And we are going to talk about matrix again. Do you remember in the last section in the previous chapter, chapter 2, we have a matrix and also Boolean matrix. So the same thing, we are going to talk about matrix here, but in a different way. What do you mean by different way? For example, I say we have a relation, between A and B, then represented by matrix. So you have a matrix relation, MR. So you know, if I multiply, if I want to make a relation between A and B, I need to cross A and B. Am I right? And I'll get this. Clear? Just a relation, it's a subset of cross A and B. So if I want to represent matrix here, I'm going to choose each element by element. What do you mean? So I'm asking myself, 1 is related with 1 in here? Hello? No, so 0. 1 related with 2 in here? 1 and 2, do I have 1 and 2? No, so 0. Do I have 2 and 1? Yes. How about 2 and 2? No. How about 3 and 1? Yes. How about 3 and 2? Yes. So the 0 means that no relation, the 1 means that relation. That's it. Easy? Then after that one, you know how to deal with the situation. If I have something like that, look at this example. I have A, I have B, and I have a relation. I have this matrix. So this example is the reverse of the first example. So show me the relation. Show me the set of the relation. How we do it? Yeah, so I don't have A1 and A2. So I have what? I have A1, B2. What else? A2, B1. You are right. A2, B3, and go on. Basha Jamaat? Clear, dears? Good. It's not clear? Depending on this matrix, Kakajan. If in this relation, if A1 is relate with the B1, I say my matrix should be by like what? 1. If I don't have it, I'm going to put 0. So how about this relation? I say that one means that A1 and B1, they are not in the relation. How about that one? I say A1 is with the relation B2. That one means that. Now you got it? And go on. How about here? I say A3, B5, they are in the relation. A3, B5, they are in the relation. You got it, dear? Hello? Easy? Good. Now we have a transpose. It's called symmetry. You remember? The matrix is called symmetry. If A is equal to A transpose. So the same thing, the relation of symmetry is what? If A is equal to A transpose. Sorry, MR equal to MR transpose. Symmetry relation. So you can find them by what? By matrix also. Okay, so tell me that relation. Tell me this relation. It's reflexive symmetry. Yalla day. Was that trick? You don't need to study actually. How do you know? Symmetry is like a mirror. If I have one here, I should have one here. If I have something here, I should have the same thing. Here, here. So they are the same? Yes. So they are the symmetry. Without using any technique. Look. This is main diagonal. Am I right? Jamaat. Like a mirror. If I have 1 here, I should have 1 here. If I have a 0 here in the corner, I should have a 0 in the other corner. If I have anything here, triangle, I should have a triangle here. You got it? So is that symmetry or not? Symmetry. Or you can find the transpose of this one. Yalla, find transpose. Khera. Did transpose? Come on. Transpose. How about that one? How about that one? Did I get the same? Huh? So is the symmetry. How about reflex? I didn't say about anything about reflex. Yalla. Let me see who's thinking about reflex. What was the reflex? Definition of reflex. Somehow. You are right, but how? No. We have a, if you remember, symmetry, reflex, transitive. So now from the matrix, you can find this relation is symmetry or not. You see symmetry just by eyes or just by the transpose. So tell me about symmetry. What do you mean by reflex? Reflex means that each member, how we say that? For each A belong to R, A and A should be in R. What do you mean by A and A? So here A11 should be 1. A22 should be 2. A33 should be 3. You got it or not? You didn't get it? I have, look, A equal to 1, 2, 3. R is what? 1 and 1, 2 and 2, 2 and 3. So tell me this relation on this A, when you say, forget about example 3, is reflex or not? We say not. Why? Because we say we don't have a 3 and 3. Now you got it? We should, if I have an A, I should have an AA. If I have B, B, 2, 2, 2, 3, 3, 3. Clear, dears? Now, how I represent that one on the matrix? Here should be 1. Here should be 1. Here should be 1. What do you mean by that? Look, Look. If I have 1, 2, 3, tell me about that one means what? 1 and 1, they are in the relation. Am I right? Tell me about that one is what? 1 and 2. Am I right? How about 1 and 3? We don't have. How about that one? 2 and 1. How about that one? 2 and 2. How about that one? 2 and 3. Am I right? That one we don't have. How about that one? 3 and 2. 3 and 3. Am I right? Then look at this relation. Is it reflex or not? 1, 1, 2, 2, 3, 3. So the diagonal is very important. What do you mean by diagonal, main diagonal? I mean this line, if all is main diagonal, if all is 1, 1, 1 means a reflex. If I put a mirror here and I go the same thing, I see the symmetry. So I use matrix to tell me the relation is symmetry or not, or reflex or not. Now, union between two relation means that, or between two matrix. Intersection between two relation of the matrix طبعا means that the first matrix and the second matrix, and you have the idea. Kindly check the previous chapter, last section about the matrix. Here we need them. So we have what? Union and R1. We have a matrix. Kindly find what? R1 union R2. So I say M R1 union R2 is equal to M R1. So it means that true, false, 1 or 1, R1. 1 or 0, 1, right? How about intersection? 1 and 0, 0. Let's see. Do you think they are hard? You saw the circle with a dot? In the multiplication of matrix. We say the multiplication of matrix. If we change it to 0, 1, we are going to use this symbol, circle multiplication. So he told you if you have two relations, S and R, and you want to find the composition of the relation and the matrix to represent, I have three things. I have R and S, two relation of greater than or equal, relation of divide by 2. So I want to composite these two together. Okay, composite. And I want to make a matrix to represent that one. سه step, okay? كم جار relation كان ديالي كم دوم جار چی كم union يان sorry composition يان اواتبون يان same يان matrix يان نسم كلا سر أوانا بشان با. So this is R, MR given طبعا this is MS. Now M is what? S circle R. أقدر با. كذا يعني توا when you put it careful you have what? R S. So you are going to multiply R multiply S. So I had two matrix. Let me call A and B. We are going to say is equal to AB matrix. يعني multiplication again. طبعا you know the rules of the multiplication, how they should be, K and M, M and N, and how is going on. So multiply here by there, you'll get this column and first column, sorry. Multiply here by there, I'll get what? 1 by 0, 0 plus 0, 0, 0, 1 by 1, 1. So I'll get 1. Understood? How about the second? I'm going to use the green. Yalla Jamaat. We have that one, multiply here. So 1 by 1, 1 plus 0 by 0, 0. 1 by 0, 0. Again, I got 1 and go on. How about Boolean? You know about the Boolean power. We have A. We say A squared is what? Is equal to I multiply A. Do you remember that? Now I have a matrix relation, and I'm going to talk about relation square. So it's equal to what? Matrix M multiplied by matrix M, and I'll get the result. I think this is the last thing, and it's easy. Yalla. We have a chapter with a graph. In the last chapter, if there's enough time to cover it, we have a graph. So in there we have a direction graph and indirected graph. Directed graph and indirected graph. Now we are going to represent relation using digraphs. How? Look at here. If somebody show me only this picture, I know what's going on. Yalla kaka. How? I say I have A with B. A with B. Also I have A, no. I have A with D, you are right. A with D. And I have what else? Nothing with A, right? So I'm going to B. I have B with what? B with D. Okay, what else? B with D. Nothing, right? But B, this is called loop. B with itself. Am I right? And go on. So C with A, C with B, and D with B, like that. Easy, right? So this is called diagram, and it's called loop. And of course, we need to represent how we have a directed graph or digraph. It's called digraph, means that directed graph or indirected graph. So generally for relation, we have a directed graph. Maybe I give you that one, I say find the digraph. Or I'll give you the digraph, I say show me the relation. Do you think you understand that question? Can you? If you have a relation, can you find this one? Or if you have that one, can you tell me about What do you say about the relation? Tell me, this figure A is a reflex or not? Huh? Yes, because each one connects with itself. So I have a B, B, C, C, like that. Tell me about that one, is symmetry or not? If I have a AB, I should have a BA. I have a AB, I have a BA. I have a AD, I have a DA. AC, CA. So it means that yes, that's a symmetry. Kindly try to study and solve what you call by the exercise.